Okay, hello from Apstra. We are going to get started on our very first webinar. Thank you so much for joining us today. We would like to begin again by saying thank you very much. We've been working on this product for about 2 years, and we're very, very excited to bring it forward in our GA release. So let us begin this journey with you guys. Apstra and our product AOS is a vendor-agnostic approach to operating modern data center networks. So on this 1-hour webinar, I'd like to, of course, introduce ourselves, our hosts for today. Derek, please introduce yourself.
Hi, this is Derek Winkworth, otherwise known as Cloud Toad on Twitter, network engineer, software person, and I work with Jeremy on our customer enablement team.
Great. Thank you, Derek. My name is Jeremy Schulman. I've been with Apstra for about over a year and a half now. I'm an automation architect. I've been in the industry for about 20 years. I'm heading up the customer enablement team, and I also go by Network Automaniac on Twitter. So on this 1-hour webinar, what we're going to do is spend a short amount of time going through some slides of our vision. And really what we're going to do here, Derek and I actually started on this journey about 4 years ago when we were accidentally exposed to DevOps. And now we're back together after that time. And when I was trying to get Derek to join Apstra, we had this really great conversation, and we're going to recreate or share that conversation with you by going through the Apstra vision. So we'll do that. And then the bulk of our time we'll spend showing you the version 1.0 of our product, or the main aspects of it. We'll have a little bit of time for a short poll just to get some feedback from you guys, and we will reserve some time at the end for some live Q&A. So for those of you that can see the question and answer section of the GoToWebinar control panel, please feel free to put questions in as we go along, and we'll try to answer as many as we can at the end. Okay, so with that, let me kind of queue up what the Apstra Operating System, or AOS, version 1.0 is at a glance, right? And this is our very first product, and we went GA last Friday. And the purpose of the version 1.0 is to allow you to design, build, and operate spine leaf data center networks. We do this in a vendor-agnostic approach, and we'll kind of explain what we mean by that. But you get to choose your vendors. In version 1.0, we support the Cisco NXOS, the 3K and 9K models. We support Arista EOS, and we support Cumulus Linux on various platforms. The purpose, of course, of our software is to provide operational simplicity with integrated real-time telemetry. And we're going to go into the complete life cycle of the product, as well as the ability to perform changes to your network, so agile change operations that folks are looking to have. Now, this is a start. We know that this is a start of a much longer journey. We had to begin somewhere, and with a set of features, and we're very actively bringing on other networking vendors and a lot more features. So we're going to show you what we've got today, and I hope you learn a lot about what we're doing, and there's a lot more coming. All right, Derek, are we ready to start sharing the Apstra vision?
Yeah, actually, well, and you know what? Before you even get started, Jeremy, I got to ask this question. As a network engineer, I've seen a lot of software products come and go in the last 20 years, and even with this last wave of SDN, a lot of the products it didn't seem like they were actually for network engineers. Who is Apstra AOS for?
Sure. Yeah, absolutely. We're building AOS for the people responsible for the network. And what we've learned over the last few years is that people are looking for what is called a force multiplier technology, which is something that allows them to do something that they weren't able to do before, or do it at scale with agility. And people want simply to have the simplicity and agility to manage data center networking without having to be, sophisticated software engineers, or without having to be programmers. And also, there are some aspects that they don't even need to be, the CCIE level, network engineers. They simply want to use their network and deploy services for their business. So we've built this technology, we built our product, with those people in mind, and also providing, DevOps around the edges types of experiences for those that want to kind of tweak it out a little bit. Does that make sense?
So yeah, absolutely. So AOS is for people who have to actually build and operate networks. But is AOS exactly?
Sure. So, AOS is, what that means is it's the Apstra Operating System, and it's an enterprise software solution. So this is something that that someone would buy and install in their enterprise, and it's a complete solution that includes applications that really are focused on network services, and these applications are vendor agnostic, right? So the user experience is vendor agnostic, meaning that they don't need to know what type of hardware or network operating system is running kind of at the device level. They have a unified way of managing network services. And those applications sit on top of a platform, and that platform is our technology that is a very sophisticated distributed systems technology that allows and accounts for the distributed nature of networking, right? Networking is a distributed systems problem. Not just the fact that we have a bunch of hardware and a bunch of different software, but because, protocols like BGP and OSPF, inherently are a distributed system. So we have a very sophisticated distributed systems technology, that's our platform. And then, following the analogy of an operating system, at the driver level, if you will, we have AOS agent software, and these agents, this is the software that is vendor specific, that kind of converts what we want the application to do into the device specific or vendor specific, how it gets done. So that's the commercial software, that's the Apstra Operating System as an enterprise software solution.
All right, so a lot of software products happen to have tooling around the product, like a lot of times like community software, little command line tools and stuff like that help them do all different kinds of things with the software. Is there something like that for AOS?
Yeah, absolutely. This is something I'm very, very passionate about and something I've spent a lot of time with. So as part of the Apstra experience, the customer enablement team that you and I are part of, we will be bringing forward a few community projects that will be available to users to kind of have that DevOps around the edges experience with our product. And we're going to show you a couple of those today as part of our demonstration. So absolutely.
Okay, so we know who it's for, and we kind of know what it is. And I'm sure we'll see a lot more of exactly what it is later. Where does this software run?
Sure. So the applications and the distributed platform run on Linux machines in your management infrastructure, right? So that's kind of in your management. And then our AOS device agents, they can run directly on the networking devices that support that environment, like the Cisco Nexus and the Arista and Cumulus. Our software can also run on the compute nodes, i.e. the servers, attached to the leaf switches. And that's optional. And that allows the user to have end-to-end control and visibility from networking all the way from the server or the compute nodes through the fabric network into your networking. And we also support an architecture that is referred to as agentless, and this is for networking devices that don't support the ability to run third-party software. So, legacy is kind of a funny word here because, our industry is moving so fast that, we're really excited to see more and more vendors allow Apstra software, third-party software to run on them, but we do account for agentless architectures.
Okay, so again, thinking back on the history of software products around networking, the vast majority of them, in terms of the network engineering lifecycle, were really only had any sort of usefulness inside of the operations phase of that cycle. When do you use AOS? Just in the operations phase or across the whole engineering lifecycle?
Yeah, you're right. We've seen a whole bunch of disparate tools, throughout the industry. You have config management tools, and you have, logging tools and reporting tools. They're all kind of disjoint and separate. But you use AOS throughout the complete engineering lifecycle. You use AOS day zero to design and create your networks. And AOS provides a set of reference designs that encode the best practices for creating these spine leaf architectures. So it's sort of like getting an army of CCIEs kind of, bolted into the product because we've qualified and verified that these reference designs work end-to-end across multiple vendors. So day 0, we have design automation tools. And then day 1, when the user needs to deploy that software or those configurations into the network, there's a seamless way to deploy that day 1 to not only provision the equipment with the initial configurations, but also validate that those configurations meet the expectation of that service, meaning, does my IP fabric actually work? It isn't just enough to push configs, but we want to know, is this fabric or is this network ready for business, so to speak? So that's day 1. And then day 2, or day N, if you will, users want an operational experience, like a holistic operational experience that allows them to do change management or perform operational tasks. Like, for example, what if I want to, add in a new leaf or a new rack of equipment, or, expand my fabric in some way? Or what if I want to swap out a vendor, vendor equipment for another piece of vendor equipment? So those types of operational activities or workflows are also a part of the AOS product. And we're going to demonstrate many of these features today.
Okay, so we have this sort of, I don't want to say a collection of tools, but we definitely have a set of tools integrated across this life cycle. Like, how does AOS bring all this together to deliver something that's new and different?
Well, what we're going to show you is AOS as a modern integrated approach to this entire life cycle of network engineering and network management. And AOS, the way that begins is with a reference design. For example, in version 1.0, we have a couple of reference designs, and I'll be demonstrating one of them. And a reference design, for example, is a 2-stage spine leaf design that uses, say, your compute nodes that attach at layer 2, like a layer 2 interface. That's a reference design. So with that reference design, the user would then express their intent, and really what that means is, what are the design decisions that the user wants to make relative to that reference design? So for example, they might want to say, I want to create a 2-stage spine leaf, but I want my spine switches to only be 32 ports of 40 gig. And we call that a design constraint, right? But these are just really decisions that the user makes relative to that design. And then based on that combination of reference design and user intent, and through the design automation tools of AOS will take that and then proceed to fabricate a set of metadata, or a blueprint, as we call it, that encodes all of this information at a meta level, so that we can then take that information in a neutral form and then create all of the configs that are specific to the devices that we want to deploy, and then know exactly the types of real-time telemetry that we want to gather. So for example, if we're doing BGP as part of this reference design, we know that we want to capture BGP neighbor information. But that real-time telemetry that we capture, we actually know what the right answer should be, and we refer to this as an expected value versus an actual value. So we could, for example, say, well, we expect a number of BGP neighbors. Do we actually have them? And by comparing those two things together, we can do anomaly detection. So we can tell the user right away with pinpoint accuracy, here's a problem, and here is what needs to be looked at or resolved. And then in combination to all of this service, there are specific change operations that people might want to make. For example, adding or removing spine leaf switches, or making operational changes. So that's what I mean by integrated approach. And from a modern, and that is also a modern approach, because we're using kind of a declarative, intent-driven approach to doing this. And we also are following some industry best practices to provide a RESTful API so that people can perform or do integration with systems if they would like. And our web user interface is using that RESTful API exclusively. And then we also provide real-time streaming telemetry from our server platforms, so that the user could get streaming telemetry right off of the AOS servers. And that streaming telemetry includes performance monitoring information like interface statistics, as well as events and alerts as they occur through this anomaly detection. So that's what I mean by modern and integrated approach.
So that's a lot of information to take in, and I'd love to actually see this in action. Let's do that.
Okay, so we're doing a live demo, and we're doing this live demo on my laptop. So what we're going to show you guys is some but not all of the product because we would just run out of time. But we will do more webinars and we will cover some more details. What we're going to do is show you aspects of build, deploy, and operate using, applying this idea of vendor-agnostic, intent-driven, and closed-loop telemetry. A lot of words there, so let's see what it means. So I'm going to flip over to my screen where you should see in the center the web user interface after I've logged in to the AOS server. And on the bottom left of the screen, I am using VirtualBox as the means to do my demonstration. And right now I have two servers running. I've got the AOS server, which is what this UI is referring to. And then I have a universal ZTP server that I'll talk about in a minute. But that's really it. So we're going to use VirtualBox, and we're going to use Cumulus Virtual Switch, or the Cumulus VX, and we're going to use the Arista VEOS as part of our demonstration. Now, how are we going to demonstrate that? What I have is a blueprint that I created. So remember, a blueprint is the result of taking a reference design and applying some design engineering criteria. And as a result, I cleverly named my blueprint Pod 1. And it's a two-stage layer 3 cloth. And if I look at this, I can, look back and I can say, well, what was the intent of my service? What is it that what I wanted to create? And I wanted to create an IP fabric that would connect 15 servers because my virtual switches have a very small, limited number of ports. And I told the system that I wanted to use a logical device that's called a spine virtual switch. Now, what that is just a logical representation of a device that I created that simply says I have 7 ports and what those ports mean. And this is entirely user-defined. AOS provides a catalog of these by default for the users to pick from that represent various hardware models and so forth. But I created one just for the purpose of this demo to represent a virtual spine switch and a virtual leaf switch. Now, I didn't say whether it was Cumulus or Arista. I just said I want something that has 7 ports. And as a result of the calculation that the AOS design automation tool does, it tells me that to support 15 servers, I need 2 spines and 3 leaves. And it also provides me some engineering information about the utilization and how many links I'm going to be using and so forth. So that was all determined by AOS based on the design or intent of our service. So what I need to do is I need to build out my blueprint. Right? I need to fill in, if you will, pieces of information so that I can deploy my blueprint into the network. And my network, of course, is in VirtualBox. Now, to create a spine leaf environment, we're using BGP, which is a standard best practice for doing these types of designs. And I've already filled in information about what ASNs I want to use and various IP addresses. And the way you do that with AOS is by using resource pools. And just as a way of example, I have a resource pool called Private ASN Pool, which is the reserved use of the high end of the ASNs. And so I'm just using that. And I tell the system I want to use this pool, and then AOS allocates from that pool and it makes the assignments across the devices. So I don't have to worry about what goes where. I mean, I can override values, but if I don't want to, I can just let AOS take care of that assignment for me. But we can see right here that we have 2 things we need to do. We need to tell AOS, the types of devices that we want to use, right? Because we have 2 spines and 3 leaves, but we haven't told AOS, what type of model do we want? Do I want to use Cumulus VX, or do I want to use Arista VEOS in this case? So that's the first thing that we need to do to finish, to move the build process along. So far, so good?
That's good to me.
Okay, so I'm going to show you how we actually make a device model assignment. Again, we're just saying what type of model. We're not saying a specific device in the network. This is just saying which model that I want. And we do this by importing what we call a logical device map. And this is what says, you want a specific, for example, model, Cumulus VX leaf switch. And this is what does the physical port mapping, or the device port mapping, to my logical port mapping. Now I'm going to bring in the virtual cumulus for both spine and leaf because I would like to make that my default. So by bringing these two in, I can see that one is for leaf and one is for spine. And so I can make this assignment like this. And so the system tells me, okay, you've given me everything I need to know about this logical device assignment. But because I want to make things interesting and I want to show a multi-vendor approach, I'm going to make one of these devices Arista Virtual EOS. So for a leaf switch, I'm going to bring in the VEOS leaf switch map. And let's say on this per node override, I'm going to override leaf number 1. Okay. So now we can see, these are the positions and what type of model that we want. Okay. So what do you think, like a network engineer would want to see just based on what they have right now? What do you think that they would want to know or take a look at?
Well, I mean, if can you see what the topology will look like, or can you see ahead of time what the configs might look like?
Sure. Because we have all of the information we need, we can actually look at a couple of things. First and foremost, we can actually get the cabling map. So this is produced as a function of the design and then the user inputs like the IP address pools and so on. And here you can see that the interface names, some of them are Cumulus named, like SWP2, and some of them are Arista named, like Ethernet 2. And this is the cabling map that is what the system should be. For example, how a facilities person should wire up the data center.
Wow, so that's extremely useful. You're doing the design, and then straight from the design, it just produces this cabling. It's basically a cabling map. This can be handed off to whoever it is that's doing the cabling in your facility, and it's known to be accurate, right? It's not transcribed from a diagram into a spreadsheet by a human.
That's right. That's right. And this information can easily be extracted via our API as standard JSON, and then it could be manipulated in other ways to produce instructions or wiring diagrams or whatnot. And maybe some of those projects could be community projects that we end up doing. But you asked about configs. Well, let's take a look at some of these configs that we could look at. For example, for Arista, if I wanted to look at any one given node in the build section, I can see information about the build process. Now, it's incomplete because we really haven't assigned a device yet, but we could still see the configuration of the Arista device as it would be applied, so that the user could take a look at it. And again, somebody could, through the API, extract this configuration as a text file or download it. So they can see exactly the configuration that would be applied. And the same is true for example, a Cumulus device. So we could look at the spine 1. And here's the config. And for Cumulus, the way that we're managing that is standard Linux practices by manipulating, files and the data that goes in the files and the commands that need to be run. And so we kind of represent this set of instructions in JSON so that the user could see this. Now, if people are unfamiliar with managing Linux networking through Quagga, they could look at what we're doing here and see exactly how one would build an IP fabric with Quagga on Cumulus.
Yeah, again, that's extremely useful. Like if you're if you have to build out some part of your data center and you're curious what it might look like if you chose this vendor over that vendor, then you can get to sample configs for a hypothetical network in in this demo it's just a matter of minutes.
Yeah, that's right. So it allows people to kind of drive the car, so to speak, without having to learn how to build a car from a pile of pieces, right? Everybody just wants to jump in your car and drive and have a good time. So that's the kind of experience that you can have with AOS, is in kind of the instant gratification. Let's get it done, let's get it operational, and then let's kind of look under the hood and see how it works. You asked about topology. We also do have a topology view. And what this is showing is it says, we're going to deploy into a 2-spine, 3-leaf scenario, but we haven't deployed anything as of yet. Everything's kind of this gray-colored node that represents nothing has been either assigned or deployed. So if we were to look at the build process, really the next thing we need to do is assign actual devices to this blueprint. And how we need to do that is we're going to create a series of virtual machines in VirtualBox, right, to represent each of these. Now, doing that by hand is a real pain, right? And doing all the virtual NIC wiring is a real pain. So what we did at Apstra as a community project is we wrote a utility, a tool, that will extract the blueprint via the RESTful API, which gives me the JSON data that I need. And from that, I am going to tell VirtualBox through the VirtualBox API to create what I want, the set of nodes and how to wire them together. So I just have the blueprint name set in a variable, which the tool will use. So this is pod 1. And I can say Verdi, AOS ETC stands for AOS Extensibility Tools for the Community. And we've cleverly named the tool Verdi. So we tell Verdi to build this blueprint. And what it's going to do is it's extracted the blueprint. It knows the model based by that mapping that we did. And it's in real time creating the virtual switches in a group in the VirtualBox Manager called pod 1, very cleverly. And it also did the wiring for each of these so that we have the virtual NICs pre-wired. So if I were to go to any one of these, and it may be a little hard to see on the webinar, but what you're seeing here is that these virtual networks, I've named them, the name of the pod / some unique number. So we can see that they're at least wired in, so to speak. Now, what we now need to do is we need to boot them up. Now these switches, imagine you just pulled a physical switch out of a box and you were in the process of just racking it up for the first time. That's what we're doing here. We're taking blank or vanilla virtual machines and we're going to boot them up. So right now I'll wait for these screens to pop up and finish. Right now AOS will show you the devices that it is going to manage, right? Because remember, we had agents that run on the devices and communicate in real time with the server. So right now, we don't see any devices in our inventory or in what we would call the device manager.
So are these devices are booting up now, and they're going to register to the AOS server? That's what you're saying, right?
Yeah. Yeah, so what's happening is they're booting up. So what's happening is they're booting up, and each vendor has a kind of a similar but unique process to do some kind of auto config or auto boot up sequence. They all involve some aspect of DHCP. They get some kind of attributes, and then maybe runs a script or something happens, and they're all different, and that makes it very difficult for most people to handle a multi-vendor environment. So as a community project, what we built is what we call the AON ZTP server. And what that does is gives the user the ability to ensure the right version of code is on the device. So, in this case, we want to make sure that Cumulus 256 is running. And in this case, we want EOS, 4.15.1F to be running. So we make sure the right version of the NOS or the network operating system is there. And we might even do a little bit of basic configuration, like maybe setting some ports in a certain mode. And then we go through the process of installing the AOS agent on it and configure it in such a way so it knows to talk back to the server. And so that AON ZTP server is a community project. We'll probably do a webinar just on it, down the road, but we'll make that generally available, for the community in the very near term. So we can see, all of our devices have booted up. We had 5 of them. And for virtual machines, we're using the serial number, if you will, is the MAC address. Now, in actual real hardware, what you would see here is the serial number of the actual physical devices.
Oh, it says quarantined. Is that bad?
So what's happening here, AOS as an intent-driven system, we didn't tell AOS anything about these devices. So they simply connected up. And by default, we put them in this quarantine state. Now, a user could put information into the system so that it doesn't enter a quarantine state, and we call that stocking information. So if the user said, well, I have this serial number and it's this type of device, in advance, then it would not enter this quarantine state. But once it's in this quarantine state, the user has to take some action, either through the UI or through the API, to make that device available to be used in a blueprint.
Okay, so how do we add it to the blueprint?
Okay, well, the first step is let's take it out of quarantine mode. So I'll do one, manually, and then I'll do the rest through the API. So, for example, this device, now I know this is our Arista device, and I know that this device is going to be Leaf 1. So the first thing I want to do is I'll acknowledge this device to let us know that this device is okay, right? And so we'll see this transition automatically into an available state, and we can see that we recognize it as an Arista VEOS. And then, as the user, I can provide some location information. In the real world, this might be, your data center name, your rack, or, rack position. I'm just going to say this is Leaf 1. This could be anything the user provides. And I'll show you where that information is clueful as we do the demo. So I'll save this. And if I were to go back, what we have is one device that's available. We know that we have active communications with these devices. That's what the little green comms mechanism here says. And we can see that I've got this location set. Now the rest of these, just because I don't want to do them all manually, I'll just say approve. And because I know information about these devices, I'm automatically approving them, and I'm automatically setting the location data as text. So now they are available. Right, I can say that this device is available, but it's not assigned to anything just yet. So far, so good?
Yeah, yep, absolutely.
Okay, so let's do the next step, which is really how do we make the assignment of a specific device, say by serial number, to the position in the blueprint. So back at the blueprint, I'll go to the devices section, and now I could click through and drop down and select these node by node. Of course, I can do this through the API, but I want to demonstrate, that I can do this through the UI. And here you can see where the location value is helpful. If as part of the user process it sets the host name would show up here, but for Cumulus VX, or Cumulus in general, it just defaults to Cumulus. So we'll save that. And we can do these, device by device for each of them. For the Leaf, this one happened to be an Arista, so only the Arista serial numbers are shown for an Arista device, just to make sure we do the right thing. And as I'm going through and assigning these devices, the system now knows that this device is going to be a part of this topology. So I'll finish this off. Do you notice anything interesting as we're doing this?
Yeah, actually, at the top I see it says alerts 3. What alerts what is it alerting on?
Well, as the device is known to the system, what's happening is the agents that are running are pushing up, publishing information to the server, and in this case, information about the interfaces that are connecting Spine Leaf. So essentially the neighbor or the LLDP information that we want. And you can see that as I'm talking, I'm not getting the right numbers assigned, so let me do that. Okay, so now we've got everybody assigned properly, and what's happening is if I go to this telemetry, I have this kind of dashboard that says, what's going on in my system and where are the anomalies. And so what's happening is it's reporting that there's some cabling anomalies, and if I were to click on that, I can see the cabling anomalies. And we're using LLDP here, and what we can see, for example, is the LLDP data has either not converged or we haven't applied the actual hostname value through the blueprint.
So wait a second, you haven't deployed these nodes yet. So is there but LLDP is configured. Do you divide the configuration up as you apply it? Like, is there some pre-configuration that happens before the rest of the config gets dumped?
Yeah. So what we do is part of that authorization process, when we go from, say, quarantine to authorized, what we do is understanding, what that kind of device is, we put it into a mode where the interfaces are up but won't pass traffic, so in kind of a layer 3 mode, but with no IP address, so traffic doesn't pass. But we do enable LLDP so we can start gathering neighborship information in real time. And if we wanted to look at the configurations on the box right now, let's say, for example, I wanted to look at the Arista box, I could look at the telemetry and see, I could look at the config deviation. Now, config deviation means, what does AOS expect there to be versus, what is there? So here we can see on the left-hand side, this is what we expect to see. So for example, we can scroll down and I can see that, for example, the interfaces, they have no switch port configured, right? But we don't have any BGP information. We don't have any service information, but there is some element of what we would call discovery configuration applied as part of this process. Make sense?
Yeah, absolutely. So it seems very principled the way you deploy the config set. It's sort of layered. You put LODP on, you verify the topology before you actually enable forwarding, and that's cool because I mean I can tell you as a network engineer how many times we've done changes where we literally just put the entire config on all at once, either copying a file or whatever.
Well, let's do that. Let's actually now apply the service configs because you can see that we haven't actually told the system that it's our intent to deploy these yet. So now let's go and tell AOS we want to deploy the first 2 spines and the first 2 leaves. We'll leave out leaf 3 for just a moment. So what we're saying is take the service configs that AOS generated, and just to give you an example, again, before I do it, if we look at the Arista switch, this config under build shows you what we're going to do, and this has specific IP addresses and BGP information. So this is the config that we're going to apply to the device. So we're going to select a collection of multi-vendor devices and apply them in a vendor-agnostic way. So I'm going to say deploy, and what the system is now doing is it's applying that service configuration. And as a result of that, we now have new expectations. We expect to see BGP neighbors, and we're looking at the routing tables on all of the devices to determine whether or not the routes exist in the routing tables in the way we expect to see them. And so you can see that we've gathered the telemetry of these devices, and we have no alerts. Right? There's nothing really wrong at this point. But if we wanted to examine the telemetry for any given device, let's say I wanted to look at spine 1. Oh, we got an alert, so we'll go back to that. So if I look at spine 1, I can see, I've got some cabling information. It's waiting for the protocol to converge. But I could look at the BGP, and I can see that even though LLDP hasn't caught up yet, I still have my BGP. My neighbors are up okay. I can look at the config deviation, and at this point, I can see that the configuration that I applied, right, my expected over here, which is all the IP fabric configuration, is as expected on the actual running device. And so as this is running, we can look at other kind of information like the interfaces relative to this blueprint. Are they up or are they not up? And finally, looking back at this topology, we can see that box number 3 isn't expected to be deployed, and spine 1, is still waiting for its protocol for the LLDP. So while that's going on, what I'm going to do is I'm going to go back to the nodes, and I'm going to apply the third one, just so that we have all of the devices in our blueprint, so we can see a fully deployed fabric. So with AOS, what you can do is you can design a fabric, but then choose when to deploy new racks of equipment or new spines and leaves. So far, so good.
That's great. So, okay, so a lot of times inside of a data center, cables don't get seated all the way, or they're mislabeled, and somebody goes in there to with a work order to cable things or recable things, and things accidentally get cabled the wrong way, or things become unseated. So how would AOS react to that?
Sure. So finally, LLDP clears. So let's virtually swap some cables, right? So here, looking back at the cabling map, right, we know what the expectation is. We know what it should be, and through the Verti tool, we can actually look at the network links in the virtual box. So here, I could do the same. Now, what I'm going to do is I'm going to swap some cables on leaf 3, for example. And so the way I'm doing this, just so you can see how it's running, even on leaf 3, what we're going to do is we're going to break the link. So imagine somebody's pulling out the cables, right? And then we're going to swap them, and then we're going to reinsert them. So I'm going to say I want to swap, cables numbered 5 and 3. And I'm going to put a delay in here just so I can stop the process midway through so you can see what it looks like when the cables are pulled out. And then I'll kind of hit enter and let it kind of continue. So what we're doing here is we basically said we're going to pull out 2 cables, and immediately we can see essentially the blast radius of what happens when you pull out cables, right? You can see we got interface errors. We obviously have neighbor cabling errors. And as a result of interfaces going down, now we have BGP neighbor errors. And as a result of BGP neighbor errors, we have a whole bunch of routing errors. You can see even leaf 1, is impacted, right? It's not seeing routes that it expects to see because of, of this cable change. And if we wanted to, we could go to any one of these devices. So I was playing with leaf 3 here. We can get very detailed information about each of these types of alerts. We can see, certain routes are missing. We can see that our cabling isn't correct because we're not getting data. We can see interfaces are down. We can then, we could drive into each of these for more detail. So on the interfaces telemetry page, we can see that, these are down and this is a deviation from what we expect. So now that I've kind of pulled the cable out, and if I wanted to go to the telemetry page, I can see that either kind of as this punch card view, or I could see this as a service view, as kind of a top-level service. I can see, how many anomalies are occurring, and we have, histograms of what's going on. Another view that we could look at is our cabling validation. So from the perspective of leaf 3, we can see that these cables are in fact, down. The red arrows, the red and the down arrows indicate the ports are down. And the dotted lines mean, well, what's the status of the cabling validation? So I'm going to hit return here, and this is going to essentially recable them, right? So the interfaces should come back up, but what we'll see is that they're going to be miswired. So you can see that it's miswired here. It's showing kind of it'll show you a complete crisscross once it's converged, but you can see that this visual representation shows you that something is actually miswired. And again, we can go back to the punch card view while that's happening. We can see that the interfaces errors have gone away, but we still have cabling errors, and as a result, we still have BGP and routing errors, right? And here you can visually see, you've got a crisscross. Now you can change the perspective. I can say, well, from spine 1, what does this look like? And you can see, well, from spine 1, port 3 should be connected to port 1, but it's actually connected to port 2. And that gives you a nice visual representation. So I'm going to swap them back, and I'll let the system do this automatically for me. So it'll just insert a 10-second delay. The tool will let you kind of pick your delay, but by default it's 10. So we'll put the system back in a known good state because there's kind of one more thing I think everybody would find very interesting. So,
Jeremy, if let's say I'm running a data center and a leaf node, like some leaf switch, has to get swapped out, and the only thing I have left is some other vendor. Can I easily swap out those 2 switches, even though they're different vendors with AOS?
Yeah, absolutely. I mean, it could be you need to swap out just a new piece of hardware for the same vendor, or you literally want to swap vendors. I'm going to show you the swapping out the Arista and putting in a Cumulus to show both of those cases. So what we would do is we would first tell the system that we don't want this device, and we would undeploy it from the topology. So I'm going to say undeploy this device. And then if we looked at the topology view, we can see that AOS knows that this doesn't need to be there, and we don't have any alerts. And then the next step that we want to do is we want to remove the serial number from this position. So we remove the serial number. So this is sort of like, if you were physically doing this, you're going to power down the switch, and then you're going to pull out all the cables. So we're going to do that virtually in VirtualBox. And the Verdi command has a mechanism to do that. We're going to say dev wire out, and in this case, I want to remove leaf 1. And so what that's going to do is that's going to power down leaf 1. As you can see, it's powered down here. And yep, it's powered down. And you can see that we removed the NICs from the virtual networks, right? So they're back kind of in a default state. So let's say that we want to replace it with a Cumulus. So we're going to use the Verdi command to say, I want a new device. I'm going to call this new leaf 1, and it's a Cumulus VX. And I want this to be as my leaf 1. And again, what this is doing is it's talking to the virtual box. So you can see we've got a new one here. And the next step is we need to tell AOS that we want to use a different model in this position. So we would go back to the node map, and we would, actually we could just say clear the override, to be honest. We could just say clear the override. And then here we've got, Cumulus. So we know that we need to wire this in as a Cumulus. So let's boot this device up. And so we're going through that process again. It's coming up as a vanilla box, or kind of a brand new box, and we'll go to the device manager, and what we're going to do is we're going to wait for it to show up as quarantine. And in the meantime, we can see that the leaf 1 that we had before, we powered it off, so there's no comms to that box, and it's kind of in this unavailable state, if you will. Okay?
Okay.
And so we have this box, and it's booting up, and right now you can see that none of the interfaces have been, virtually wired into the blueprint just yet. So I'm going to kind of do this step by step, just kind of with maybe as a network engineer would do, like, power the box in, make sure the boxes come up. We can see the box is registered with AOS. It's in this quarantine state. You can see all the information about the device, like serial numbers, the version of code that's running on. These are typically what people would call facts, in the automation lingo world. So I'm going to approve this, and I am going to, maybe I'll set the location as, replacement leaf 1, and now it's available. So going back here, I can look at leaf 1. We can see that it's not assigned yet, but if I wanted to, we could see, what AOS did from a config perspective. We can see that the configuration that we intend to apply is now a Cumulus configuration. This used to be an Arista for leaf 1. And we need to finish the step of assigning the serial number. So we'll go to the devices, and we'll assign the serial number. We can see this is our replacement leaf. I'll save that. And then once that is done, it says this is now in a deployable state, so I will deploy this. And as that is being deployed, I'll go to the dashboard view to watch, the errors going on here. We can see that we have some interface errors because we haven't yet wired in this device. So let's wire that in. Dev wire in host name. And then this is new leaf 1. And so what this is going to do is this is assigning those NICs to the proper virtual networks and turning them up. So you can see in real time that the interfaces are starting to clear, and the BGP and the routing information is already converged. And once again, we have some slow LLDP cabling. But at this point, from a system level, we have this view, and we can say, well, from a BGP perspective, everything is okay. So we know that we could actually pass traffic. Even though from a cabling perspective, we're still kind of waiting for LLDP to converge. And that's really the extent of the live demo that we have time for. I'm looking at the clock, and I see I've gone over by about 5 minutes, and I apologize. So because I really want to get to the poll, and I really want to get some of the user questions. So I'm going to go back to the slide deck here, and very quickly, we didn't have time to cover this in the in the demo, but there are other reference designs than I showed today. One of the other really interesting reference designs that we're seeing is where the compute nodes are actually running a routing protocol. So this could be bare metal servers running containers, and they're using Quagga or some kind of routing protocol to actually do BGP between the compute servers and the leaf nodes. And this is an architecture or reference design that we support. And our agents running on the servers, on the left-hand side of the screen, you can kind of see a visual representation of what that would look like with a bunch of compute nodes connected in, and we have visibility and control, and we provision and manage the routing protocol on the server, so in this case Quagga, and the networking configuration on the NICs connected to the leaf switches themselves. So that's kind of showing on the left side. On the right side, what we're showing is actual real hardware, because doing a virtual demo on a laptop is one thing, but this is what it would look like. I took a snapshot of one of our lab setups where we're using a mixture of both Cisco and Arista for both the spines and the leafs, and then some hard servers, with our agents running on those servers. And that's kind of a multiple vendor, network deployment. Both of these is a separate kind of reference design. The intent, of course, is an IP connectivity service, but here is where we move the layer 3 routing boundary from the switching fabric and into the server or the compute nodes. Cool? Okay, so I would love everybody's feedback on a few short polls. So the way this works is I'm going to open up a poll. Everybody will have a few, just a quick sec to respond to it, and then I'll close the poll and show everybody's response, so everybody gets to see what it looks like. So here we go. I'm launching the poll. Hopefully you can see this. It says, are you now or in the future using a spine leaf architecture? What we're seeing right now is some people are doing it. Some people are thinking about doing it. Some people, have a kind of a legacy layer 2 approach. So if everybody would quickly answer, and we'll see how, what everybody's doing. So we got 42% voted. Let's wait a few more seconds. 50% voted. Come on, everybody, vote. Vote, vote, vote. We're going to share the results. So if you're not, say, an end user, if you're somebody who is, say, a systems integrator, or if you're an analyst, answer this question in terms of think in your mind, is this something that, generally speaking, I've got customers doing, or the people I talk to from an analyst point of view is doing. I know that these were written kind of in the mind of, somebody who would buy and use AOS, but I expect, some of the folks on the webinar may not be those people, so kind of think about it that way. Okay, we've got 68 voted. I am going to, in the interest of time, close the poll here and see what we've got. So I'm going to share the results, and we can see 44% are using spine leaf now, and a good chunk are considering it, and with a lot of expectation. So only 13% are not considering using the spine leaf. I think this is really telling. Maybe a few years ago it was different. I hope you see that with AOS, it's a very easy approach to doing these types of architecture. So, maybe if you weren't considering it before because you thought it might be too hard or it might be too complicated, I hope you see with our product that it could help there and it won't be so complicated. All right, the next one's a really kind of a yes/no one. So here, are you the kind of customer that would be interested in a vendor-agnostic approach to operating the network? Meaning, are you looking for a tool like Apstra's AOS? Some people are using only one vendor, but they still are looking for a vendor-agnostic approach, meaning I don't want to have to know all of the minutia of commands and controls for every single device or every change of a version in a device. So even if you're using only one vendor, you could still take a vendor-agnostic approach. So that's what we mean here. And again, if you're not sure what vendor-agnostic means, maybe I didn't explain it very well. So mark it there, and I'll try to do better. All right, we're getting faster at the voting. This is great. All right, 61%. I'm gonna close the polls just because I got two more, and I'm gonna try to get to one question or two. I really apologize for going long in the demo. We'll definitely do more webinars. Okay, so let's see what the results are. Okay, well, this is good news. Like, everybody would really like a vendor-agnostic approach, right? And some of you are not so sure, but I'll try to explain that a little bit better next time. But thank you for that feedback. Okay, let's go to the next one. There's only two more questions. You talked about having a layer 3 protocol running on the compute node. We introduced that very, very at the end. Are you using that kind of architecture now? Is it something that you're planning to use maybe as part of your, container deployment strategy at your company? Is it something you're just mildly interested in looking at, considering? Perhaps a tool like Apstra would make that a lot easier to approach. At least you could try it out. You could definitely try it out in a virtualized environment. Or is putting layer 3 routing protocols on a compute node just not something you would consider doing? So I'm going to definitely wait on this one just a little bit longer because I'm really, really curious on this. I'm seeing a lot of interest and a lot of buzz in the industry about this approach. And it's something that we've been working on with some very early customers specifically to support this, and I'm glad that we did. I'm going to close the poll here in about 5 seconds, so get your answer in there. Okay, I'm closing the poll. Let's share the results. So this is really interesting. 26% of you guys are actually using this architecture now. That's really amazing. And 8% of you have plans to do it within a year. For those of you that are considering to do this, please, I hope again you see that a tool like the Apstra AOS could really help you out and kind of maybe get you over the kind of, wow, this is going to be too hard, or what's going on kind of thing. All right, final question. And this is a multiple choice, so you can kind of select, many of these answers, and pick all the ones that you're doing. In terms of, any kind of automation that you're doing right now, versus all the manual steps that you're doing. Are you using any types of tools to automate the design process that goes from, reference design to some kind of set of configurations as a result of that reference design? So that's what the first one means. The second bullet means, are you using automation to template build configs and push configs. Basically, that's kind of like that idea, the automated process of building configs and pushing them. The third bullet means, are you doing any kind of automation to gather telemetry relative to the services that you care about, not just gathering all the data and then have no relationship to the service, but, gathering the telemetry on a continuous basis. I mean, sure, it could be with SNMP or it could be with, some scripts that you wrote, but are you doing anything like that, but doing it in a network services context? And the fourth bullet is are you doing any kind of anomaly detection and reporting based on what you expect the state of the network should be versus not the state of the network? And that could be either config deviation. That's really just talking about network state, because the last bullet is about configuration deviation. Like, are you detecting configuration deviation, and are you doing any kind of automated remediation? So, oh man, I'm looking at the clock, and I've got 2 minutes left, and I am not going to have time for questions. Maybe one. I might go a little bit longer. All right, I'm going to close this poll, and we'll share the results. So we're seeing a really good mix, and this is something that I see a lot of. A lot of folks are building, using automation tools to build and deploy configs, and then this is a nice mixture to see what's going on, relative to other parts of the engineering lifecycle. So thank you, everybody, for providing your feedback on this, because I think this is really insightful, and I think as an industry, as we kind of continue on this automation and networking journey, we're going to hopefully see a lot of these, a lot more coverage across the space, and hopefully with AOS. So with that, that kind of concludes the poll, And thank you again. I'm sorry we didn't get a chance to cover the live Q&A. For everybody that provided questions, we will either respond one-on-one to you, or we may post general questions and answers on a blog page, where we'll also include a link to more information about the webinar. I'm really sorry that we weren't able to answer the questions, but I appreciate you guys sending them in. So again, in conclusion, the Apstra Operating System is really built for the networking folks to deliver in a business-oriented way, a business intent-driven way. And this is really just the start. We've been working really hard. This is version 1, and there's a lot more coming. So please, join the journey with us. You can visit us at our website at apstra.com. You can, there's a way you can schedule kind of a deeper dive product demo. We've got some really interesting white papers. And then you can stay updated with us on some blogs. Derek will be writing blogs again. I'll be writing blogs again. We've got, our CEO and our CTO will be writing blogs. We'll be definitely doing more webinars and events. And then you can follow us on the social media, both on LinkedIn as well as Twitter. So thank you, everybody, again. I really appreciate everybody's joining us for this very first webinar. We're going to do more webinars next month, and I hope you can join us for those as well. Thank you very much.